Okay, so here we have the VPLS for Superlab 2. Now we have 3 VPLS sites. We have a VPLS hub on router 2. We've got VPLS site 1 and site 2. We're going to be configuring them on router 2, router 7 and router 8. Okay, so the first thing you have to do is get the interfaces ready. So we've got apply groups accept, because obviously we're not wanting to be running MPLS over these interfaces. Obviously these are PCE interfaces, so they're bridging at layer 2, so it's wide area bridging. So we've got flexible VLAN tagging, allows us to put the VLANs on. Encapsulation flexible Ethernet services, got the encapsulation here, we've got the VLANs. We're doing that on 2, 7 and 8. And now we have our routing instances. So set routing instance VPLS, instance type VPLS, VLAN ID 1500, put the interface in there, the route distinguishers and the route targets. And again, we're using these AS specific route distinguishers. We type in no tunnel services. It's really just something that you have to know. It allows it to encapsulate and de-encapsulate the packets, and it's required so that we can actually store the MAC addresses, as we see down here on the interface inside the site inside the VPLS. Okay, and then we have a site identifier. Now the site identifier actually matches the PE number, not the actual site number. So site 1 we're actually calling site 7, site 2 we're calling site 8, and VPLS hub we're calling site 1. There's a reason why we're doing that. By calling the hub site identifier 1, it means that on router 7 and router 8, when we put the site range 2, it means that these sites can peer with site 1 or site 2. It would mean that if we had another hub coming to make it redundant, there'd be space. And then by indicating on router 7 that it's site identifier 7 in the VPLS, it prevents site identifier 7 from connecting with site identifier 8, which is obviously on router 8. So a little bit oblique there. On the actual site names, we've got site 1 and site 2. In the VPLS, we're calling them site 7, site 8. We're allowing them to peer to site 1 or 2. In this case, that's the hub, site 1. Okay then, so what else do we have? Well, as I stated down here, inside the routing instance, name VPLS, inside the protocol VPLS, inside the site, name, and of course that site name is inside the protocol VPLS, inside the routing instance. We go right into the site here and we go onto the interface inside the site, and that is where we put the MAC learning. And of course, this isn't EVPN. Each individual routing instance can learn their own MAC address tables. They're not sharing them. It's not a single MAC learning bridge. It's multiple MAC learning bridge working together. Okay, we've got some normalization issues here. The first normalization we can see on router 7, it's VLAN 1050. And that's incredibly easily normalized. Just inside the VPLS instance, we put the correct VLAN ID and it normalizes in and out on the interface. And you can actually do that. If you look at show interface G003.1050, it will actually show you right there on the interface that that it'll be taking 1500, dropping 1050 and vice versa. Very, very useful view there. And the second little bit of normalization is up on router 8. However, this is really interesting what happens here. So here we've got an outer and an inner tag, and we can see them here on this interface. So VLAN tags outer 600, VLAN tags inner 1500. And you've got this little input VLAN map and output VLAN map. And you can see that it's popping on the way in and it's pushing on the way out. And what that means is that as the packet comes into the interface from the CE, it's going to be popped. And as we put the interface out to the CE, we're going to push it. So the CE sees this double stack, and when we come to routing, we're seeing the single, and the outer is popped at 600, and then we can actually bridge the inner 1500 out of these VPLS sites, and that's VPLS Superlab 2.